rectangular arrangement of numbers. This is called matrix. That means the numbers are arranged in rows and columns. For example, this is the first row. This is the first column. So the number A is in first row, first column. This is the second column. A is in first row, second column. A is in first row, third column. A is in first row, fourth column. Like that, it goes on. A is in first row, nth column. So total there are n columns in this matrix. Coming to second row, A is in second row, first column, second row, second column, second row, third column, second row, fourth column, second row, nth column. Third row, A is in third row, first column, third row, second column, third row, third column, third row, fourth column, third row, nth column. Like that, there are many rows. This is mth row. That means there are m rows. So A is in mth row, first column, mth row, second column, mth row, third column, mth row, fourth column, mth row, nth column. Like this, the elements are, numbers are arranged. Elements means numbers only. You can call elements as numbers or numbers as elements. The elements are arranged like a rectangle. In this rectangle, there are m rows and n columns. So order of the matrix is m by n. M denotes rows, n denotes columns. You should not say m into n. It is m by n. And then you will put a square brackets like this. For the rectangular arrangement, this becomes a matrix. You can give a capital letter to name the matrix. So the matrix A is this particular matrix. Or I can in short say, in the matrix, the elements are like A, I, J. I are the rows which start from first row to mth row. J's are the columns which start from first column to nth column. And the order of the matrix is m by n. So in short, you can write the matrix A like this also. Now matrices are of different types. Types of matrices. The first one is row matrix. In row matrix, there is only one row. Nothing else. Like this. 2, 3, 5. There is one row but 3 columns. This matrix B is called row matrix. Column matrix means there is only one column in the matrix. There is only here only one row, here only one column, nothing else. Like means matrix C 2, 3, 5, only one column. There are 3 rows but one column. So order of the matrix is 3 by 1. The next type of matrix is rectangular matrix. Rectangular matrix means the rows will not be equal to columns. The number of rows will not be equal to columns. For example, in matrix T, we will take 2, 3, 5, 1 minus 7 minus 6. We are taking 2 rows and 3 columns. So number of rows, number of columns, not same. That is why it looks like rectangle, and so it is called rectangular matrix. So once you know rectangular matrix, immediately you will know square matrix also. Square matrix means it will look like square. So number of rows will be equal to number of columns. For example, in matrix E, suppose there are 3 rows and 3 columns. There are 3 rows and 3 columns. 3 by 3 is the order. Or you can even say order is just 3. 3 by 3 or 3, you can say. It looks like a square. That is why it is called square matrix. Next, the 5th kind of matrix is called zero matrix. In this, all elements are 0. For example, it can be a square matrix like this. O, 2 by 2. 2 rows, 2 columns. All elements are 0. Or the zero matrix O can be like a rectangle, 2 rows and 3 columns. 0, 0, 0, 0, 0, 0. Like this also it can be a zero matrix. Then the next one, 6th one is diagonal matrix. Diagonal matrix means, suppose the matrix F is there. First of all, it must be square matrix. Diagonal matrix should be square matrix, whose all elements are 0 except diagonal elements. So only diagonal elements are not 0. Non-diagonal elements are 0. So diagonal elements not 0. Non-diagonal elements are 0. So which definition would be better? This definition will be better. Instead of saying diagonal elements not 0, you have to say non-diagonal elements are 0. So this is the diagonal. 0, 0, 0, 0, 0, 0. Here 4, it can be 1, it can be 0 also. That's why I did not comment on diagonal. Diagonal elements may be 0 or may not be 0. We are not one. But non-diagonal elements will be 0, have to be 0. Such a matrix is called diagonal matrix. In short, you can write this as diagonal 4, 1, 0, like this also. So basically in diagonal matrix, diagonal elements, non-diagonal elements. So Aij, if I is equal to j, these are called diagonal elements. And Aij, if I is not equal to j, that means they are non-diagonal elements. So I can write in diagonal matrix, Aij will be 0 for I not equal to j. This is the definition of diagonal matrix. Non-diagonal elements are 0. That is what I'm saying. Then scalar matrix. What do you mean by scalar matrix? Seventh one. Scalar matrix is first of all a square matrix. Then it is a diagonal matrix. But the diagonal elements are same. That means Aij is equal to k for all I equal to j. So the diagonal elements will be same, like 4, 4, 4. The non-diagonal elements will be same. Such a matrix is called scalar matrix. The next is identity matrix. What is identity matrix? Scalar matrix in which diagonal elements are equal to 1. So if diagonal elements are 1, non-diagonal elements are zeros, then it is called identity matrix. It is denoted by I. Identity matrix. The next is upper triangular matrix. What is upper triangular matrix? If Iij is equal to 0 for I greater than j, then it is upper triangular matrix. I greater than j. So where I will be greater than j? A to 1, A to 3, A to 3 can't be taken. A to 1 you can take. I is greater than j. A 3 1, A 3 2, all these you get. Remaining elements may be 0, may not be 0. 7, 5, 6, 0, minus 1, 2, like this. This is upper triangular matrix. What is lower triangular matrix? In lower triangular matrix, Aij will be 0 for I less than j. I less than j means what? A 1 2, A 1 3, A, 2, 3. Remaining may be 0, remaining may not be 0, like this. So this is upper triangular matrix. This is lower triangular matrix. If you are not able to follow anything, you comment in the box and stop me so that I will explain again. Okay. Next is we will learn about algebra of matrices. In matrices, you have algebra also. You can add two matrices of same order. If the order is same, you can add them. For example, you can add, you can subtract, anything. Add or subtract. For example, I'm giving you two matrices of same order. This is matrix A and this is matrix A, B. We have to add A and B. How can we add A and B? Corresponding elements you have to add. 2 plus root 3 and 2. You have to add. Then root 5 and root 5. Add up. Then minus 1 and plus 1. Add up. 0 and minus 2. Add up. 3 and 3 you are adding. 0 and 1 by 2 you are adding. So because the matrix A is of order 2 by 3, matrix B is of order 2 by 3, both the orders are same. That's why we are able to add, and A plus B also will be of order same 2 by 3. So you will have 4 plus root 3, 2 root 5, 0, minus 2, 6, 1 by 2. This is A plus B matrix. Then properties of addition. When you add matrices, I will put the properties of matrices. I'm not writing, I'll put it on the board. These are the properties of addition of matrices. What are the properties? See, A, B, C are matrices, 3 matrices of same order. Then A plus B equal to B plus A, that means it is commutative property. A plus B plus C is equal to A plus B plus C. This is associative. A plus 0 matrix is same as 0 plus A matrix, which is equal to A. 0 is called additive identity. Then A and minus A, if you add, you will get 0 matrix. Minus A and A, if you add, you will get 0 matrix. So minus A is called additive inverse of matrix A. Then there is cancellation law. If A plus H equal to A plus C, or actually it is not A plus H, it is A plus B. A plus B is equal to A plus C. Then you can cancel A both the sides and write B equal to C. If B plus A equal to C plus A, you can cancel A on both the sides and you can write B equal to C. So these are the properties of addition. Similarly, we can do subtraction also. How to subtract two matrices? Suppose A matrix and B matrix are given to you. You have to do A minus B. That means corresponding elements you have to subtract. 2 minus 1. 4 minus 3. 3 minus of minus 2. 3 plus 2. 2 minus 5. Okay, so now this will be equal to 1, 1, 5 minus 3. So this is how you subtract the matrices. Now the next property is scalar multiplication. What is scalar multiplication? Suppose I give you a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose you are multiplying A by a scalar number. Scalar means a number like 5 or minus 5. Then each element you have to multiply with minus 5. 1 into minus 5, 2 into minus 5, 3 into minus 5, 4 into minus 5, 5 into minus 5, 6 into minus 5, 7 into minus 5, 8 into minus 5, 9 into minus 5. This is called scalar multiplication. Now for scalar multiplication also, there are some properties. What are the properties? Quickly, I will paste. Suppose you have matrix A and matrix B. Then a number lambda into A plus B is same as lambda A plus lambda B. This is lambda B. Similarly, A plus lambda into A is lambda A plus lambda A. Lambda and mu are numbers, lambda plus mu into A. Actually, this property is not written correctly. I will write here. Lambda plus mu into A. It will be lambda A plus mu A. Then lambda into mu into A will be lambda into mu A, or it will be equal to mu into lambda A. Anything. In any one of the ways we can. Minus lambda into A is minus of lambda A, which is A into minus lambda. Any one of the ways. All the three ways are one and the same. The next is multiplication of two matrices. This is the toughest, it is the difficult one of all. Suppose A is a matrix. Okay, I will write the heading first. Multiplication of two matrices. A is a matrix Aij. Order is m by n. B is a matrix Bjk. Order n by p. See how it is. Here, jth column. Here, jth row. Here, n columns. Here, n rows. Like that it should be when you multiply two matrices. So when you multiply A and B, you will have Cij elements and the order will be m by p. This will be the order of the matrix. And how will you get Cij? How will you get this Cij? You have to multiply all Aij's and Bjk's, and then you have to add. Sigma means adding. I will be from 1 to m. J will be from 1 to n. And k will be from 1 to p. This matrix will be of order n by p. What do you mean by this? When you expand multiplication, what do you mean? For example, in A, you will have A11, A12, A13 up to A1n. A21, A22, A23 up to A2n. A31, A32, A33 up to A3n. And so on, AM1, AM2, AM3 up to AMN. There are m rows, n columns. Suppose B has B11, B12, B13, so on up to B1P. B21, B22, B23 up to B2P. B31, B32, B33 up to B3P. Like that, BN1, BN2, BN3 up to BNP. So there are N rows and P columns. See here N columns, here N rows. That is very, very essential. So A into B will give you C. And in C, how the matrix C will be? M by P. That means M rows, P columns. So C11, C12, C13 up to C1P, C21, C22, C23 up to C2P, C31, C32, C33 up to C3P, and CN1, CN2, CN3 up to CNP. This is the multiplication of the matrix. But how will you get C11? How will you get C11? How will you get C12? How will you get C13? Or how will you get C21, C22, C33? All these. So C11 you will get by taking first row, first column and multiplying and then adding. You have to take C11 means first row, first column. So what are the elements of first row, first column? A11 you have to multiply with B11, A12 with B21, A13 with B31, like that. And add A11, B11. Next what? A12, B21. A13, B31. So on. What will be the last one? A1N, BN1. A1N, BN1. How will you get C12? First row, second column. You have to multiply first row. This is first row and second column. So that means A11, B12. A11, B12. The next, A12, B22. A12, B22. Then A13, B23. Is it B23? B32. So on A1N, BN2. So when you multiply, you see here 1, 2, 2, 3, 3, N, N. And apart from that, what you can see here? 1, 1, 1, 1, 1, 1, 1, 1. Same here, 1, 2. 1, 2, 1, 2, 1, 2. Whereas in the middle, what you have? 1, 1, 2, 2, 3, 3, N, N. The same pattern will continue. For 1, 3, A1, B3. In the middle, 1, 1. Here, A1, B3. In the middle, 2, 2. Next, A1, B3, in the middle 3, 3. So on, A1, B3, in the middle NN. Like that. Now I know second row, first column. I have to multiply second row, first column. So what I will have? A2, B1. In the middle, 1, 1. Here also A2, B1. In the middle, 2, 2. Here A2, B1. In the middle, 3, 3. So on, A2, B1. In the middle, N. Like this way. Then you will multiply second row, second column, second row, third column. Like that it continues. You can write all the elements of matrix. The next is transpose of a matrix. What do you mean by transpose of matrix? Suppose the matrix A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then A transpose or A dash, what will happen is, first row will become first column. Second row will become second column. Third row will become third column. So if A is having 3 rows and 4 columns, A transpose will have 4 rows and 3 columns. This is A transpose. Next, we have properties of transpose also. Properties of transpose means A dash, double dash, A dash, whole dash will be A. A plus B whole dash is A dash plus B dash. KA whole dash is K into A dash. AB whole dash is B dash A dash. Remember this. Last one, AB whole dash will be B dash into A dash. The next is conjugate of a matrix. What do you mean by conjugate of a matrix? Conjugates usually you will see in square roots and complex numbers. Like suppose A is having 1 plus 3i, 2 plus root 3, minus 5 minus root 5, and minus I. Then A conjugate or A bar will be conjugate of 1 plus 3i is 1 minus 3i. Conjugate of 2 plus root 3 is 2 minus root 3. Conjugate of minus 5 minus root 5 is minus 5 plus root 5. Conjugate of 0 minus I is 0 plus. This is called conjugate matrix. Now there are some properties of conjugate matrix. For conjugate also there are some properties. The properties are A dash whole dash is A. AB whole dash is A dash. Actually there is equal to in the middle. A plus B whole conjugate is A dash plus B dash. And AB whole dash is A dash into B dash. Ka whole dash is K into A dash. What is conjugate transpose? There is something called conjugate transpose also. What do you mean by conjugate transpose of a matrix? Suppose you have a matrix like this. This is the matrix A. First, we will take conjugate. 2 minus 4i, 3 plus 0i, 3 minus 0i. 5 plus 9i, 4 minus 0i will become 4 plus 0i. Alpha minus beta I plus 3i will become minus 3i. 2 will be same, minus 5 will be same. 4 minus I will be 4 plus. After conjugate, you have to take transpose. First row will become first column. Second row will become second column. Third row will become third, like this. This is conjugate transpose. Now there are some special types of matrices. Already we have learned types of matrices. Now some special types of matrices. Among them, the first one is idempotent. If A square and A are same, then the square matrix A is called idempotent matrix. That is one type of matrix. Then there is one rule for this idempotent matrix. Let me put that rule. If A and B are idempotent matrices, A plus B is also idempotent. Okay. And then AB will be idempotent if AB is equal to minus B. Next, nilpotent. If A power K is 0, A power K minus 1 is not 0, then the square matrix A is nilpotent matrix. What is involuntary matrix? Any idea? What is involuntary matrix? Very easy. If A square is equal to I, identity matrix, then you call the square matrix A as involuntary matrix. What is symmetric matrix? A square matrix A such that A dash is equal to A. That is called A transpose is equal to A. That is symmetric. There are some more properties of symmetric matrices. One thing I told you about symmetric matrix is A dash will be equal to A. But apart from that, if A and B are symmetric matrices of same order, then AB is symmetric if AB equal to B. The same thing I told you about nilpotent, idempotent also. What did I tell you about idempotent? If AB is equal to minus BA, then AB is idempotent. Some rules like this there will be there. The next, A plus or minus B, AB plus BA are also symmetric matrices. If A is symmetric matrix, A minus I is also symmetric matrix. The next is about skew symmetric matrix. This skew symmetric matrix I will paste. What is skew symmetric matrix? So these are the about skew symmetric matrices. A square matrix A, you can call it as skew symmetric matrix if A dash, that means transpose of A, is minus A. Now, if A and B are two skew symmetric matrices, then A plus or minus B, AB minus BA, these are called skew symmetric matrices. But AB plus BA will be symmetric matrix. Determinant of a skew symmetric matrix of odd order will be 0. That is false. And then every square matrix can be expressed as sum of symmetric and skew symmetric matrix. That means if you have A, you can write it as half of A plus A dash plus half of A minus A dash, where half of A plus A dash is symmetric matrix, half of A minus A dash is skew symmetric matrix. Now I will give you one problem, you try. Multiplication problem. Try this and tell me the answer. Because for a long time I was explaining, just listening will be boring. Try this. Multiply A and B and say which answer is correct. Yes, very good. Komala, very good. Option B is correct. Option B is correct. How? You are multiplying 6923 with 260798. So multiply first row, first column. Add up 12 plus 63. Multiply first row, second column. Add up 36 plus 81. That is enough actually. So you will have here 75. Here you will have 117. That is present only in option B. You need not multiply all. Just first row, first column, first row, second row. That is it. Yes, Suhas. What's your doubt? Any questions, Suhas? You did not say anything, Suhas, so I'm proceeding further. Now we have, for multiplication of matrices also, we have some properties. These are the properties of multiplication of matrices. What are they? A, B, C are three matrices. So usually, always AB will not be equal to B. Sometimes it may be, but not always. A into B plus C is, this is not correct. I will write it. A into BC will be equal to AB into C. So the first one is commutative property. The second one is associative property. Then A into B plus C is AB plus AC. Next, identity matrix into A is same as A. A into identity matrix is same as A. But here, the order of identity matrix should be M. Order of identity matrix here should be N. Because A is of order M by N. See, if I is of order M by M, and A is of order M by N, then only you can multiply. M columns, M rows, you can multiply. Similarly, A is of order M by N, I should be of order N by N, then only you can multiply. Because here N columns, N rows. Okay, next property. A into IN will be equal to A into identity matrix will be equal to identity matrix into A. Both will be equal to A if A is a square matrix of order N. If AB is a zero matrix, then A need not be 0, B need not be 0, A and B need not be 0. A need not be equal to 0, B need not be equal to 0, or A and B both also need not be equal to 0. Still AB will be equal to 0. That is a special case about property of multiplication of matrices. So with this, we will end the class. In the next class, we will discuss about more properties and problems also we will do.